So far we have discussed force between two bodies when they are point charges. Now let's see what happens when one of the body is not a point body. Let's find out force of a ring charge. It's a ring having charge Q, its radius is R, and we need to find its force on a point charge Q which is placed on its axis at a distance of x from the center. This is a ring charge. And Q is a point charge. And if you write force like this, K into Q divided by x square, then this answer is wrong. Because we know that this formula is applicable, this form of Coulomb's law is applicable only when both bodies are point bodies. Whereas in this case, this is the ring charge and this is the point charge. Then how do we find force for a question like this? First thing we do is we break this ring charge into several point charges. Ring is made up of these several point charges. The topmost one, let's say this is dq. dq means something which is very small charge, and therefore automatically dq becomes a point charge. Remember, q is a ring charge and dq is just a point, and therefore is called a point charge. Any point charge on the ring is at a distance of root over r square plus x square from this point charge q. What is happening? We have a ring charge q. This radius is r. Right here is your dq. This distance is x. This is the position of small q. This is x, this is r, and therefore this distance is root over r square plus x square. Force of dq on q, they both are point charges, is dF. Since it's a small charge, force is also very small, which is dF. And this force can be written as k into q into dq divided by root over r square plus x square whole square. We can use Coulomb's law because both charges are now point charges. Now, if I ask you to calculate F, then normally people do this. They integrate dF. But this is wrong in this situation. यहाँ तक सारी कहानी सही है, but this is wrong. And why is it wrong? Because if you find force of these small point charges on Q, which is placed right here, then these forces are pointing in different directions. And as forces are pointing in different directions, you cannot directly integrate them. You can directly integrate a force only when all the forces are pointing in same direction. Whereas in this situation, these forces are pointing in different directions, and therefore we cannot integrate df like this. तो अब क्या किया जाए, क्या करेंगे, देखना है इस चीज को. This force of dq on this q is pointing in this direction. That's your df. If this angle is theta, then this angle is also theta, the opposite angle. Now take components of df. This component is df cos theta, whereas this component is df sin theta. So this dq is having two components. One is along the axis, which is df cos theta, and the other one is perpendicular to the axis, which is df sin theta. Now, if on this ring charge you take the bottom point charge dq and you find its force right here at the position of q, then this force is also df, and this force is also at an angle of theta. Now when you take the components, this component is df cos and this component is df sin. Now if we consider effect of this dq and the bottom dq, then force on this charge q is like this. Now these two forces, they are having their df cos theta components along the axis, but their df sin theta components are pointing exactly opposite, and therefore this df sin theta cancels this df sin theta. And this happens for all the point charges which are diametrically at the opposite end. And therefore we say that when you need force F, instead of integrating df, you must integrate df cos theta. What does it mean? It says that dq का इस q पर जो फोर्स आ रहा है df, ये पूरा का पूरा df हमारे काम का नहीं है. उस df का केवल cos थीटा कंपोनेंट हमारे काम का है, और df sin थीटा कंपोनेंट डायमेट्रिकली ऑपोजिट dq के फोर्स से कैंसिल हो जाएगा. इसका मतलब केवल कंट्रीब्यूशन किस चीज का बचेगा, df cos थीटा. दैट मींस इस पूरी की पूरी रिंग पर जितने dq हैं, सबके dq फोर्सेस जो आए हुए हैं df के फॉर्म में, उनके cos कंपोनेंट्स को पकड़ो और उनको उठाकर ऐड कर दो, and that will give you a total force. Let's see how we integrate df cos theta. तो इस df cos theta को इंटीग्रेट करने के लिए हम क्या करेंगे? We need to find cos theta first. And then how do we find cos theta? Well, you can see a right angle triangle right here. This is the radius r, this is theta, and therefore cos theta in this right angle triangle is x divided by root over r square plus x square. Now this f, which is the integration of df cos theta, can be written as df, which is k into q, multiplied by dq divided by r square plus x square multiplied by cos theta, which is x upon root over r square plus x square, x upon root over r square plus x square. यहाँ तक पहुंचने के बाद कई लोगों को लगता है कि इस तरह के फंक्शन को किस तरह से इंटीग्रेट किया जाए। कुछ लोग लगता है बहुत डिफिकल्ट इंटीग्रेशन है, लेकिन इंटीग्रेशन की एक कहानी है कि जितनी भी चीजें कांस्टेंट होती हैं उनको हम इंटीग्रेशन साइन से बाहर ले लेते हैं। तो क्या क्या कांस्टेंट्स है देखते जाना। k, q, and if you see x, it's also a constant. Whatever dq charge you take on the ring, this distance is always x, and therefore x does not change. और अगर x चेंज नहीं होगा तो ये पूरा का पूरा पोर्शन कांस्टेंट बना हुआ है। तो अगर ये कांस्टेंट है तो ये बाहर आएगा इंटीग्रेशन साइन के, और बाहर आने पर आपको क्या दिखाई देगा, r स्क्वायर प्लस x स्क्वायर, दिस इज पावर 1 and this is power half, which makes it power 3/2, and the thing which is left inside is only what, dq. Now what is the meaning of integration of dq? Integration of dq means sum of all these point charges which are present on the ring. तो इन सारे के सारे रिंग चार्जेस के पॉइंट्स को अगर आप ऐड करोगे तो अल्टीमेटली हमें क्या मिलेगा, टोटल चार्ज which is present on the ring, and therefore integration of dq will get you k into q into x multiplied by q. Integration of dq is simply what, q divided by r square plus x square to the power 3/2. So this is the force which this ring charge exerts on a point charge which is present on the axis at a distance of x from its center, and its format is like k into q into x divided by r square plus x square to the power 3/2. And if somebody needs vector form, then we'll write force like this. First you need magnitude. We know the magnitude is k x divided by r square plus x square to the power 3/2, and the force is pointing along the axis. This direction is I cap, and that gives you the direction. So this is the magnitude, and this is the unit vector for direction, which completes the force on the charged ring. Let's again summarize the whole thing. हमारे पास एक रिंग चार्ज था, उस रिंग चार्ज का अपने को इस पॉइंट चार्ज पर फोर्स निकालना था। डायरेक्टली कूलम्स लॉ एप्लीकेबल नहीं है क्योंकि ये रिंग चार्ज है और ये पॉइंट चार्ज है। तो हमने क्या किया, हमने इस रिंग चार्ज को छोटे छोटे पॉइंट्स में ब्रेक किया। जैसे ही हमने इसे पॉइंट में ब्रेक किया, ये भी पॉइंट चार्ज है और ये भी पॉइंट चार्ज है। अब हम कूलम्स लॉ यूज कर सकते हैं इस फॉर्मेट में। लेकिन अगर अपने को टोटल फोर्स चाहिए तो इस df को अभी हम इंटीग्रेट नहीं कर सकते। क्यों नहीं कर सकते? क्योंकि ये अलग अलग df के डायरेक्शन अलग अलग हैं, और इंटीग्रेशन का मतलब होता कि सारे के सारे वेक्टर्स दे आर पॉइंटिंग इन द सेम डायरेक्शन। इसलिए हमने क्या किया, हमने इस df के कंपोनेंट्स लिए cos एंड sin, एंड देन वी सॉ दैट ये जो कंपोनेंट था df sin, ये इस बॉटम dq के df sin से कैंसिल हो गया था। तो जो सर्वाइविंग कंपोनेंट्स हैं दे आर ओनली व्हाट, df cos। तो जो टोटल फोर्स निकालना था दैट विल बी इंटीग्रेशन ऑफ df cos थीटा। cos थीटा की वैल्यू फाइंड की, उसको पुट किया। अब ये इंटीग्रेशन एक बिल्कुल सिंपल फॉर्मेट में है। x कांस्टेंट होने की वजह से बाहर आ गया, अंदर बचा हुआ है dq। सारे के सारे dq's को अगर ऐड करेंगे, इंटीग्रेशन सम सारे dq को अगर आप ऐड करेंगे देन यू गेट व्हाट, q। जैसे ये q मिला, ये आ गया आपका फोर्स। दिस इज द मैग्नीट्यूड। इस मैग्नीट्यूड में अगर आप डायरेक्शन फिट करेंगे तो आपको दिख रहा है कि फोर्स कहां लग रहा है, along the x axis, and therefore this is the direction part which is I cap. That's how we calculate force when both bodies are not point charges. We use what, integration. Fundamentally we are still using Coulomb's law like this.